In this video lesson, we are going to talk more about tangent, secants, and chords. So this will be the first part of a two-part lesson. So we want to recall three different things. When we have two inscribed angles that intercept the same arc, they have the same measures. So for example, up here in this circle, notice that angle ADB, its intercepted arc is AB, and then angle AEB also has that same intercepted arc. So we know that this angle and this angle are going to be equal to each other because they have the same intercepted arc. The two other things that we talked about, if you have intersecting chords inside the circle, then the measure of the interior angle, so this angle right here, is half the sum of the intercepted arcs, meaning that you would add, right? That's what sum means. You would take x plus y and you would divide by 2, and that would give you this interior angle, and this one as well, right? Because these are vertical angles, so it would give you both of those. Now, if you have lines, any type of line, two tangents, a secant and a tangent, or two secants, then the measure of that angle, okay, of this angle where they intersect at, is the half the difference of the intercepted arcs. And you always want to take the bigger arc minus the smaller arc. So for example, x is bigger and y is smaller, so you would take x minus y and divide it by 2. Here's the bigger one, here's the smaller one. So you would say x minus y divided by 2. Bigger, smaller. X minus y divided by 2. Okay, so today we're going to talk about tangent segments. Okay, a tangent line to a circle intersects the circle at exactly 1 point. So we already know that. So here we have line J and line K, and these are tangent lines. A tangent segment is a segment of a tangent line, and it has to have one of its endpoints at the point of tangency. So for example, a tangent segment here would be line AP or BP right here, okay? So you has to have A has to be a part of the segment, and B has to be a part of the segment because it has to be where it touches at the point of tangency. And then one of our tangent segment theorems is that if two tangent segments intersect at an exterior point, then they are congruent. So for example, here we have tangent segment AP and tangent segment BP. So here's where they intersect at the point of tangency, or here's their point of tangency, and here's where they intersect. So we know AP equals BP, or is congruent to BP. So here it says which segment is a tangent segment to circle Q. And then we want to explain why the other segments are not tangent segments, okay? So here it gives us EP, okay? If we look at EP, all right, it hits this circle in 2 spots. So this is actually a secant line. So that's why EP cannot be a tangent segment. Now let's look at CD. Now CD is a tangent line, right? It only touches at 1 point. But remember, a tangent segment has to touch the circle. One of the points has to be touching the circle. So since it's CD, we can't say that that's one of the endpoints, right? Neither one of the endpoints are touching the circle. Now ED, here if we look at ED, okay, now this is a tangent segment, and one of the endpoints, right, E, is touching the circle at the point of tangency, so that would be your tangent segment. And then here if we look at BP, don't get confused on this one because it looks like, oh, well, here's B, here's an endpoint that's touching it at 1 point, and then B, but actually you got to look at the line, right? This line that BP is attached to is a secant line, so that would not be a tangent segment. Okay, the line has to be tangent. Here it says AP and BP are tangent segments of circle Q. If AP equals 10 centimeters, find the length of BP. So our rule that we talked about earlier, right? Tangent segments that intersect at 1 point are equal to each other. So we know BP is also 10 centimeters. On this one, it says, what is the value of X if AP and BP are tangent segments? AP is going to equal 10x minus 15, and BP is going to equal 7x plus 3. So here we want to find the value of X. Well, what we know is that AP is congruent to BP, So what we can do is just set these two equations equal to each other and solve for x. We can say 10x minus 15 equals 7x plus 3. Now what I would do is add 15 to both sides and subtract 7x from both sides. So that's going to give me 3x equals 18. And I divide by 3, I'm going to get x equals 6. So there we go. X is going to equal 6. And if you wanted to actually find the length, right, you could just plug that 6 back into the x. Okay, our other rule that we're going to talk about is that if two chords intersect in the interior of a circle, the products of the segments of one chord are equal to the product of the segments of the other chord. So for example, AE times EB is going to equal CE times ED. So here, we want to determine the length of segment CE if AE equals 10, EB equals 6, and ED equals 5. So our theorem, or our law that we talked about earlier, right, is that the products are equal to each other. So we know that 10 times 6 has to equal 5 times x. Okay, 10 times 6 is 60. And we're going to divide by 5. And so we get x equals 12. So we know that the length of CE is going to equal 12. This says, what is the length of AE if EB equals 6, CE equals 3, and ED equals 10? So here again, we know that 3 times 10 equals 6 times x, right? Because x is our unknown. So we have 30 equals 6x. Divide by 6, and we get x equals 5. So we know that the length of AE is going to be 5. This one, it says, what is the length of CE? So we'll label that x because we don't know it. EB is going to be 5 centimeters, AE is going to be 6 centimeters, and ED is going to be 3 centimeters. So here we know that 6 times 5 is going to equal 3 times x. So 6 times 5 is 30. And then we're going to divide by 3, and we would get x equals 10. So I know that segment CE is going to equal 10. And that's the end of the first part of tangent, chords, and segments.